So now we're going to go over tuples. And tuples is not a new concept that has been introduced in C# 7. Rather, it has been renovated so that it is a much cleaner syntax and much more intuitive to work with. And I'll see that just in a minute, but first I want to explain what tuples are and then explain you what problem tuples have solved. So first thing, tuples are a data structure that provide a single set, so a way to represent a single set of data. But the question is, why have tuples been introduced at all? So oftentimes, there is a need to be able to return more than one value from a method. And before tuples, there were three ways to do that. One was out parameters, so returning variables by reference. And then it was the class or structs, so you would bunch up the variables in a class or a struct and then return it that way. Or anonymous types returned through dynamic return type. But these three ways just begged for a new concept that would just do it easily, and that's why tuples have been introduced. However, there's one caveat. Working with tuples is not so intuitive, and so C# 7 has made it so that it is clean and intuitive, and so that people can start using them, because this problem comes up a lot when people want to return more than one value from a method. So that people don't have to go around and create classes just for one method to be returned from. They can just use tuples and be okay with it. And now we're going to go ahead and do just that. I already have my tuples class. And if you didn't already do that in your managed NuGet packages for solution, or rather, we can do it for our project because we only have one project. So you right click, you go to manage NuGet packages. And then for here, if you don't have installed system value tuple, then you need to go to browse and type in system.value tuple. And you need to install it. In this case, I can because I already have installed it, but you would just click install and then you would say agree and accept and then go with that. And that would install this library on your project. The reason why you need to do that once again is because this value type has been extracted out of C# 7 and it is a separate thing out there that is being developed. But as the time goes by, these things will be introduced to the new frameworks and there will be no need to get these packages separately. So with that said, let me go ahead and show you how a tuple has been created in the old way. And you can still do it in C# 7. It's backwards compatible. So we're going to go ahead and do just that. I'm going to say tuple. And then inside of that, I'm going to say I want to have a string, I want to have another string, then I want to have an int. And I'm going to call this old tuple. That's it, old tuple. And I'm going to have a method called getOldTuple. Great. And then let's go ahead and actually create this method. And I will now take this out. And I will say return tuple dot create, and then you would simply say what you want inside of the tuple. In this case, I will say Mark, that's the first name, and then I will say Wilson, and then I will say 30. All right, and that'll return it here, and we'll have it inside of our old tuple variable. And then I will say console, write line, and let's write some stuff here. I will say 0, 1, and 2. Or you can even use the $, and inside of this, just put whatever variable you want to print out. In this case, I will say old tuple, and it'll be .item1. Then it'll be item2, and then item3. Great. But here's the thing though. You see this item 1, item 2, item 3, and do you also see the order, the string? So you can put multiple types in your tuple. And then when you return values back, you don't really know what this value stands for. And then by the time it comes here and you say item 1, you don't really know what this is. So that's what I meant when I said not intuitive. Because this can be coming from another class and then you just get it and you just don't know how to use it. I mean, what is item 1? As long as there's documentation, you can understand it. If somebody tells you what item 1 stands for, you can use it. But if you don't know, then it's going to be very hard to figure out what item 1 is. So once again, not very intuitive. So let's go ahead and start writing tuples in the new C#7 syntax, but this will still not show you the power that has been introduced. This is still us going to be doing the same thing, just in C#7 syntax, just so you can see the difference, and then we'll get into the new features. So I will say unnamed tuple, because you can do this multiple ways. That's why I want to kind of create its own section. So we'll say var new unnamed tuple, and then I will say get new unnamed tuple, and console write line, and inside we will simply have the same thing. So I can actually copy this. I just have to change the name. And I will say new unnamed tuple. There you go. And create the method. So this method, here's what it's going to return. It's going to say the following. Return, however, it's not going to say tuple.create. It's simply just going to have parentheses, and then inside of the parentheses, you will just put your tuple values. Now this returned an object because it doesn't know what we want to return, but here you would, the way we do tuple, string, end, or any type you want in it, you would do the same thing with parentheses. So it's a lot more simplified. And then you would put the types inside of it. So you would say string, and then int. And there you go. You would get back a tuple, and then you can use item 1, item 2, and item 3 just the same way we did it with the old way in order to get the items from the tuple. Once again, not intuitive, so this is kind of using the old way but with the new syntax, and we can go ahead and do this in a couple of more ways. Now the second way, we're going to use deconstruction. Remember deconstruction where you're grabbing specific values from a custom type? We can do that with a tuple as well, just like with custom types. So we are going to go and say var, and inside of that, I will say first name v1. The reason why I'm versioning the variable names is because the variable names, I don't want them to clash because I'm going to do a couple of examples, so I'm going to version them, and these variables are in the scope of the entire method. So if I have first name twice, it just won't work. That's why I'm versioning them. That's the only reason. So I will do that, and then for this one, it's going to be last name version 1, and then it's going to be age version 1, and it's going to say get new unnamed tuple. So that's it. Now it's getting the same tuple back. Imagine that you can do it these two ways. One is assigning it inside of just a regular variable and then using the items inside of that variable. The other way is to use deconstruction. So you're getting back the tuple and then you're deconstructing the values and assigning them into separate variables. So in this case, this int will go into age 1. The string is going to go into last name v1. The string is going to go into first name v1, right? The question is, how do you access this? Very simply, you just use the variable names. In this case, instead of using the item 1, item 2, and item 3. So this is a little bit more intuitive, as you can see. So I will say first name v1, last name v1, and then age v1. And that should work. Once again, a bit more intuitive. Another way you can do it is by having var in front of each variable. So just to be more specific that all these are going to be vars. The reason why it's underlined red is because the names I have to change. That's why I versioned them. And there you go. Everything works now. I just have to change these as well. So it prints the appropriate values. And there you go. Another way in which you can deconstruct, though, is by being a lot more explicit. So what you can do is you can say, hey, listen, var is very implicit. What I want to know is what this type is. So you can say string is first name is going to be string, last name is going to be string, and age is going to be an int, right? So in this case, you are being a lot more explicit when you're deconstructing the values. And that way, you are just a lot clearer as to what these values represent. So that's another way in which you can deconstruct. At the end of the day, these are all going to get you the values that you want, but it's just for you and other developers to just follow a certain style, whichever one suits you better. Now we're going to go over named tuples. So I will say, let's go ahead and say this. First name. So I'll actually copy this because it's going to be pretty similar. And I'll bring it down. And in this case, it's just going to be version 4 because we already have version 3. So version 4. And this guy is going to say, it's a new method, get new named tuple. So now let's go ahead and create this new method. So get new named tuple. And this is going to return pretty much the same as the unnamed tuple. However, the difference is in the signature. So remember how this was string, string, and int? Didn't really tell you what it's returning back. But with named tuples, what we can do is we can say, hey, listen, the first one is going to be a first name. Second one is going to be a last name. And by the way, I have 2 return statements. Let me take one out. That's because of the copy paste. And then the third one is going to be age. So now you're very clear about what is being returned and what's going on. And by the way, the reason why it's underlined red is because the age has to be after, you have to type, and then the variable name. So that's it. And now we are assigning that to this deconstructed variable set. And so in this case, you notice that even though I say that my named variable has to be first name, last name, and age inside of a tuple, I can deconstruct it into other variable names that have nothing to do with this. So that's just an example to see that just because this is named, you can do the same thing as with the unnamed tuple. You can take out the values that you want and put them into variable names that you desire. So I'm going to go ahead and print this out. I will go ahead and say version 4 for this, version 4 for this, version 4 for this, right? And now let's do one more thing. Just like with the unnamed tuples, you can also specify the type of the variables when you're deconstructing inside. So you can say this is a string, this is a string, and this is an int. Just like with an unnamed variable or unnamed tuples. So it's the same thing. Nothing is different so far, except the method down here, which is a little different. But the way we're accessing it is pretty much the exact same way as we're accessing the unnamed tuple. And so version 5. And now you will see the power of named tuples in this example. I will have a variable called new named tuple. I'm not deconstructing it. Then I will say get new named tuple. But here's the beautiful part. You might be asking, well, now we should be using item 1, item 2, item 3, right? Not anymore. If you grab this value, if you grab the variable rather, it is going to allow you to access, see this? Instead of item 1, item 2, and item 3, you can access specific names and know exactly what value you're accessing. So in this case, we're saying, I want the first name, then I want the last name, then I want the age. See how beautiful this is? You didn't really need to create a class or a struct. You didn't have any out parameters, and you didn't have any anonymous types being returned through dynamic return types. Nothing complex. All you do is you specify the types and the names, and you return your values, and then you access them by their names. Very intuitive, very clean. So if I actually go ahead and run this, I will go ahead and get this here and say tuples equals new tuples. And I will say tuples.run, and this should do it. Now, let's actually stop here, and you will see when I go to run, you'll see that here, Mark Wilson 30, fine. And it's going to print out the same thing, so it's actually a lot more interesting to see what the values are. So item 1 is Mark, item 2 is Wilson, item 3 is 30. This is the new syntax, but it's doing the same thing. When you deconstruct, values come into these variables, so you can access them easily through the variable names. And you can do it in different ways. But then with named ones, you can do the same thing that you did with unnamed ones. So nothing different here. However, when you get here, see in the named tuple, you have all these beautiful property names. First name is Mark, last name is Wilson, age is 30. And you also have their types. So you can access them like this without creating any extra code in between. Very clean once again, and very intuitive. And this is an amazing new feature that has been added to C# 7. But that's it for now, guys. I hope you've enjoyed these updates. A lot more will be coming through since C# is always going to be supported and it's growing in popularity. So you're in good hands if you're learning and mastering C#.